3, 2, 1. Okay. Thank you, ladies and gentlemen. You will be with me next 15 minutes, and I want to talk to you about data storage, a compression that really makes the difference. So I'm Michele Costantino Soccio. I work for Amadeus. It's a travel company. We do everything about travel. If you took a flight to come here, probably we handle your ticket. If you didn't get a seat that you like, probably that is my fault. And if you also paid it too much because you said, okay, yesterday it costed $100 and next day it costed 120, that one is also my fault. I work also on the revenue management. So most of you will know that it's well known that there are only two human-made objects that are visible from space. One is the Great Wall of China, and the other one is the Amadeus Revenue Accounting Oracle DB. So why is that? Because we, in revenue accounting, in Amadeus, we do the bridge between the airline world and the financial world. So it means that we help the airline to keep their books in order and to answer to any audits, calculate the taxes that they need to pay to the airports, to the different governments, and also to handle all the interactions they would have with their partners. For example, if you take a flight, if you buy a flight on an airline website, but one of the flights is operated by different line, they need to exchange some money at a certain point, and we help them doing that. And to do this, we need to record all the financial transactions of the airline passengers operations. Every time you buy a ticket, every time you ask for a refund, every time you exchange, every time you take the flight, even when you take the flight, because when you take the flight, that amount that you paid becomes a revenue, if you know about the accounting rules. So this one you can imagine, if we need to record all these informations and we need to keep the data for like maybe 10 years, has some impact on our database. So, and this is a problem. And why is a problem? Because it will make your database more expensive. So it's a problem in terms of cost, and it's also a problem in terms of operability. You take more time to do a backup. You take more time to do a restore in case of a disaster, which never happens in Amadeus, of course. So, I've already talked about several of the solutions that we put in place to drastically reduce the size of the database in another talk. If you want to have a look at it, or you can ask me after this session. So, what I want to talk to you about during this session is about a certain point. We thought, okay, we have so many documents, we have so many events for each document. Is there a way to compress them better? Is there a way to make a compression that could really, literally make the difference? So what happens is that for each document, every time there is an event, we record a complete new image of the document, okay? It's a protocol buffer, and it is usually compressed in GZIP with maximum compression, and it works so far quite good, but now we started to have a very large database. So we thought, since we have only very little changes between each version of the document, is there a way that we can store only the differences? And that way is the VCDIFF standard. It is an RFC. You can implement it. And the advantage of this compression method is that completely format agnostic. So it will take the original image that you have, okay? It will compute a difference, and then if you have the original version and the difference, you can compute a binary perfect copy of the file or the object or the document or anything that you want to do. So what we do, we basically take the first version of the document, and instead of storing each version that come after that, we store only the difference from the first one. Okay? But of course, talk is cheap. Show us the code. Let's see. I should have a VS Code here. So, what I want to do, I want to see if I can. Beat JPEG. So we do with the protocol buffer is a fairly long protocol buffer, but let's take an image. I will try to do some drawings from which you will see that why I became a developer and didn't become a painter. And we will see if with this method, the second image with the drawing, we can store it in a format that is smaller than the JPEG. It could work or it could not work. Okay, we will do it live. So the photo that I choose, downloaded. Okay, why is not duplicate? Sorry. So the photo that I choose is this one of London. On my laptop, it looks nicer than this. Okay, and we will try to do a drawing. First thing, let's do the drawing. So the image. Oops, this one is not accessible. Home. VS Code. VCDIFF. I will remove the things I did before. So you see, I don't have anything in my sleeves. I will open it with GIMP or GIMP. How do you say it? GIMP? GIMP. Okay. I'm Italian, I would say GIMP. Like GIF or GIF. Okay, so you can see that there are a few boats there, but I always dreamed of having my own boat. So I will add one. So I will add one here. Okay. It's very nice. Okay, you like it? Now what I will do, I will export the image. I will just add devox here to store the difference. Okay, I will use this whatever GIMP is proposing me. And I forgot to do the one thing, is that I will take the original image, okay, and just I will resave it to make sure that we are using the same JPEG compression in both sides. Export, save. Okay, so now you see that we have these two images, and they are 5.2 megabytes. Now, let's write some code to do the compression. I have 8 minutes. Let's speed up. So, I have my main. I want to accept some input parameter. Oh, okay, thank you. And then expect 3 arguments, base, target, and delta output. I don't like this. Okay. Give me a better one. Okay. If argc 4 just want, okay, so that I remember return 1. Okay, so this one is what we need. I have already written some functions just to read and write the files for convenience. Okay, so now const standard string base. I will read the base, the first argument. Then the target will be the second argument, and the delta, standard string delta. So this one, the delta, is where we will store the output of the difference between base and target. Okay, so far? Now, how do I do the compression? We go to the VCDIFF implementation done by Google. We copy this one. We paste it here. Of course, this include goes up here. I also need to include my io.hpp, and since I'm here, I will also include iStream and strings. And here, what we do, yeah, much better. We create an encoder. The dictionary is the base, so I'll just use base and base here. This one is an optional flag that we don't need it. And then I will encode. I will say, okay, with the encoder that is based on this base, I want to get to the target. Give me the delta that will get that target, okay? And then after that, I will just do a write. Okay. And am I missing something? Return one, Oh yeah, you're right. I was just seeing it red. Okay, so now let's remove build. Okay, if you will in build, we do cmake and do a make. I have a compress, and then I can do a build compress and the file Benjamin something.jpg. I want the target should be the one with the boat, and the output, let's say devox.delta. So far the delta you see is 2 megabytes instead of 5 megabytes. You could trust me that that is correct. Okay, do you trust me? No, okay. It happens. So let's do the decompress. For the decompress, I will just copy paste decompress and expect 3 arguments: base, delta input, and output file. Base, delta, and output. I read the base, I read the delta, and here I have the output. Instead of having the decoder, here we'll have the encoder, I will have the decoder. Since I'm lazy, I will again go to copy this one. I also need to change the header. Here, this one. Again, this one I called base. Okay, looks good. There is something red here, I don't know why. Removed lines, okay, nothing important. I go again, I redo my make. Target was not declared, because I called it. I asked you if it was okay, you didn't notice it. Okay, so we are with the decompress. So now build, decompress. I give you the base, that is the original JPEG. I give you the delta, and how do we call the output? I don't know. Result.jpg. Okay. Let's see. Result. Decompress. It didn't work. Why it didn't work? The line 21. Yeah. Target. You're right. Thank you. Build, make. And decompress. Result, the size is correct. Shazam. The checksum is the same, and let's see if the result has my little boat. And that's it. Thank you so much. And this is how we saved a few terabytes of space on a very large Oracle database. Thank you.